Hiya! So this time we're going to look at another example of a continuous probability distribution. But this time I'm actually going to give you the probability density formula. So the probability density formula is given by this. So this is the probability density. Well, I guess I say it here. And I'm saying that x is my variable. So I'm basically asking, okay, well, what is px greater than 3? And what's the expected value of x? So let's kind of figure this out. So probability is obviously going to be the easy part, right? So here we have p of x greater than 3. So this translates into 3 to infinity because we're looking at everything above. We take our formula because here we're x greater than 0, so that's okay. 1 over 1 plus x squared dx. So this one, it might seem a little complicated if you haven't done before or like how to solve it. But hopefully you have seen this and how to kind of look into this. But basically what we have is this should be equal to minus 1 over 1 plus x from 3 to infinity. Okay, so we have minus 1 over 1 plus x. So if you're kind of confused, basically what I did is in my brain, I did a u substitution of 1 plus x. And here you'll notice that you just switch dx and du. So basically it's not really doing much. And then so this 1 over u squared, I subtract 1 from the exponent. Or sorry, I add 1 to the exponent, so I'd get minus 1 instead of minus 2. And then I multiply by that new exponent, so minus 1. And you can verify that this is the antiderivative if you haven't done this in a while. So take the derivative and try it out. And so if we plug in numbers, we get minus 1 over 1 plus, I'll put infinity here. You should all know that technically this is wrong, right? If you don't remember why this is wrong, come ask me. But this is technically wrong. You can't just plug in infinity. Infinity is an idea. It is not a number. 1 over 1 plus infinity basically means 1 over infinity, which goes to 0. So this is just 0. Plus 1 over 1 minus 3, which is minus 2. So we get minus 1/2. I did something wrong. Oh, this is not a minus. It's a plus. That's why. This is plus 1/4. There we go. 1/4. I was like, wait a second. This should be positive. I should not get a negative probability. See? How to catch your errors real quick. So yeah, so the probability that x is greater than 3 is roughly 1/4. Nice. All right, so what's the expected value? Well, expected value is basically minus infinity to infinity. We just take everything. X times my formula. So 1 plus x squared dx. Notice here how we're defined over x greater than 0. So technically I can just make this go away. Go away. Why is it not going away? Okay, there we go. Make it 0. Okay, nice. So what is this equal to? So at this point, we're going to have to do the u substitution that I had done before. That I had done in my head. So if I let u equal 1 plus x squared, or 1 plus x, then I end up getting du is equal to dx, and I get u minus 1 is equal to x. So here if I substitute these in, and then also I need to change my variables, right? My bounds. So 0, 1 plus 0 gives me 1, and infinity plus, or 1 plus infinity equals infinity. So these are the bounds. So here, by u substitution, I get 1 to infinity, and I substitute in. So x on top becomes u minus 1. On the bottom, 1 plus x becomes u squared, and then here dx becomes du. So it's not too bad of a problem. But the reason why we did this is because now I can split this up into u over u squared minus 1 over u squared. And that's much easier of a problem to solve. So here I have 1 over infinity of 1 over u minus, or du. I can split this up, right? 1 over u squared du. 1 over u, this is just a natural log of u from, I guess I can do this afterward, and then minus 1 over u, right? So technically this becomes a plus, so I can just make this plus, I guess, 1 over u. And then I will look at all of this from 1 to infinity. So what is this? This is natural log of infinity. Again, this is technically wrong. Plus 1 over infinity minus natural log of 0, or 1, sorry, minus 1 over 1. So let's see what these give me. This gives me 0, this gives me 0, this gives me 1. And natural log of infinity is actually infinity. So what do we have? We have infinity minus 1, which is infinity. So our expected value is infinity. Welcome to continuous distributions. Even though the probability is really small, we have a 1/4 probability that x is greater than 3, our expected value is infinity. Think on that. It's a little exciting. It's a little weird. Welcome to continuous distributions. It's bizarre. Anyway, so we'll leave it at that. And then in the next video, we will look at empirical distributions. So I will see you then.